What happened?
My math teacher just sent me an email and he told me that I have to solve a math problem, but I don't even know where to start. And he told me that if I don't solve it for tomorrow, I'm going to fail the topic and I'm not going to graduate.
Oh no.
I don't even know that this topic existed. I don't know what I'm going to do. Help me.
We have to calculate the area between f of x equals secant cube of x, the x-axis, and the vertical lines x equals minus p over 4 and x equals pi over 4. We also have to build an approximation rectangle whose width will be of pi over 12 and whose height will be of f of pi over 8. We are going to integrate the function in the x-axis and we will use integration by parts method to integrate the function.
So we have the function secant cube of x and we're gonna use the integration method by parts. And first of all we have our function that is the antiderivative of secant cube of x dx equals to the antiderivative of secant square of x times secant of x dx. And our data is u equal to secant of x, du equal to secant of x tangent of x dx, v is equal to tangent of x, dv is equal to secant square of x dx, and our formula that is the antiderivative of u dv equal to uv minus the antiderivative of v du. So following the formula, we have the first part of our antiderivative is secant of x tangent of x minus the antiderivative of tangent of x secant of x tangent of x dx, and we are gonna multiply the second part of the antiderivative and we're gonna try to simplify as much as possible until we can integrate, and our result is 1/2 times secant of x tangent of x plus ln of secant of x tangent of x plus c. And our final result simplified is secant of x tangent of x plus ln of secant of x plus tangent of x plus c over 2.
In order to get the area of the region we are asked to get, we have to use the first theorem of calculus, which states that if f is continuous on the closed interval ab and f is the indefinite interval of f on a to b, then the integral from b to a of f of x dx equals f of b minus f of a. So here we have to substitute the values of pi fourths and minus pi fourths into f and subtract. So by using integration by parts and the first theorem of calculus, we know that the area between f of x equals secant cubic of x, the x-axis, and the vertical lines x equals minus pi fourths and x equals pi fourths is of
First, read the problem and understand it. Second, investigate the theory part. Third, solve the problem using integration by parts, knowing that x is equal to pi over 4 and x is equal to minus pi over 4. U is equal to secant x. Du is equal to secant of x tangent of x dx. V is equal to tangent of x, and dv is equal to secant square of x. Then the answer we got is secant of x tangent of x plus ln of secant of x plus tangent of x all over 2 plus c. Then calculate the area using the first theorem of calculus, and the area is 2.2955871 units squared. Finally, make the flowchart and the conclusion. Some of the uses for integrals are in engineering to optimize the space, as well as electromagnetics, electric circuits, and heat transfer.